Good day everyone, I'm Teacher Teens and welcome to my YouTube channel.
In this video, we will discuss about geometric mean. Geometric means are the terms to be inserted between two non-consecutive terms of geometric sequence. For example, number 1, insert two geometric means between 5 and 40. So first is we're going to illustrate the given problem in example number 1, wherein we have 5, a sub 2, a sub 3, and the last term is 40. So the geometric means that will be inserted between 5 and 40 will be the second term and the third term. And then next is we're going to determine the value of a sub 1, that is the first term, which is 5. And the last term, or that is a sub n, that is equal to 40, and the value of n is 4. So 4, we have 1, 2, 3, 4. So there are 4 terms in example number 1. That's why the value of n is 4. Next is we're going to solve for the value of r, or we're going to determine the common ratio of the given geometric sequence. And the formula in finding the value of r, or the common ratio, we have r equals n minus 1 root of a sub n over a sub 1. Next is we're going to substitute the value of n, a sub n, and a sub 1 in the formula, and we have the value of n is 4, the value of a sub n is 40, and the value of a sub 1 is 5. So after the substitution, we're going to simplify. We're going to get the difference of 4 and 1, and we will also divide 40 by 5. So we have 4 minus 1 is equal to 3, and 40 divided by 5 is equal to 8. And then next is we're going to determine the cube root of 8. And 8 is the same as 2 times 2 times 2. The factors of 8 are 2 times 2 times 2. And that is also the same as 2 cubed. And we can write now the cube root of 8 into the cube root of 2 cubed. And then we're going to simplify this one, so the value of r is 2. The common ratio of the given geometric sequence is 2. Next is we're going to solve for the value of a sub 2, or the second term, wherein the formula is a sub 2 is equal to a sub 1 times r. And we're going to substitute the value of a sub 1 into 5, and the value of r is 2. So we have 5 times 2, and that is equal to 10. So the second term is 10. Next is we're going to solve for the value of a sub 3, and that is a sub 2 times r. The value of a sub 2 is 10, and the value of r is 2. So we have 10 times 2, and that is equal to 20. So the final answer now in example number 1, the two geometric means between 5 and 40 are 10 and 20. For example number 2, insert 3 geometric means between 2 and 512. So first is we're going to illustrate the given problem. So we have 2, and then a sub 2, a sub 3, a sub 4, and the last term is 512. So a sub 2, a sub 3, and a sub 4 will be the 3 geometric means that will be inserted between 2 and 512. So the first term is 2, and the last term is 512. The value of n is 5 because we have 5 terms in the given geometric sequence of 1, 2, 3, 4, 5. So the value of n is 5. Next is we're going to solve for the value of r using the same formula in finding the value of r. And then we're going to substitute the value of n into 5, a sub n into 512, and a sub 1 is 2. So we have this one. So 5 minus 1 is equal to 4, and 512 divided by 2 is equal to 256. And the factors of 256 are, we have 4 times 4, that is 16, times 4 is 64, 64 times 4 is equal to 256, and 256 now is equal to 4 raised to 4. We have 1, 2, 3, 4. So that is the same as 4 raised to 4. And then we're going to simplify now the fourth root of 4 raised to 4, and that is equal to 4. So the common ratio now of the given geometric sequence is 4. Next is we're going to solve for the value of a sub 2, and that is equal to a sub 1 times r. A sub 1 is equal to 2. The value of r is 4. So we have 2 times 4 is equal to 8. The second term now is 8. Next, the third term, that is equal to a sub 2 times r. A sub 2 is 8, and the value of r is 4. So we have 8 times 4 is equal to 32. And we're going to solve now for the fourth term, or that is a sub 4, that is equal to a sub 3 times r. A sub 3 is equal to 32, and then the value of r is 4. So we have now 32 times 4 is equal to 128. So the fourth term is 128. So therefore, the final answer will be the three geometric means between 2 and 512 are 8, 32, and 120. For example number 3, insert two geometric means between 108 and 4. So for the illustration of the given problem in example number 3, we have 108, a sub 2, a sub 3, and the last term is 4. So the two geometric means that will be inserted between 108 and 4 are a sub 2 and a sub 3. So this will be the two geometric means that will be inserted between 108 and 4. So next step is we're going to determine the value of a sub 1. So that is 108. The value of a sub n is 4. And the value of n is 4. So we have 1, 2, 3, 4. So there are 4 terms in the given geometric sequence. Next is we're going to solve for the value of r. We're going to substitute the value of n, a sub n, and a sub 1 in the formula. So we have the value of n is 4. The value of a sub n is 4. And the value of a sub 1 is 108. And then next is we're going to simplify this one. 4 minus 1 is equal to 3. And then we're going to simplify 4 over 108. The greatest common factor of 4 and 108 is 4. So 4 divided by 4 is equal to 1. And 108 divided by 4 is equal to 27. And then simplify. So the factors of 27 are 3 times 3 times 3. And that is equal to 27. And if we're going to simplify, so that is equal to 3 cubed. So 27 is equal to 3 cubed. And then, so we can write now the cube root of 1 over 27 in the form of the cube root of the quantity 1 over 3 cubed. And then we're going to simplify. The value of r now is equal to 1/3. And then next is we're going to solve for the value of a sub 2. So that is equal to a sub 1 times r. A sub 1 is 108 and the value of r is 1/3. So 108 times 1/3 is equal to 36. The second term is 36. Next for a sub 3. So that is a sub 2 times r. A sub 2 is 36. And then the value of r is 1/3. So we have 36 times 1/3 is equal to 12. So a sub 3 is equal to 12. That is the third term. So the final answer now, the two geometric means between 108 and 4 are 36 and 12. Let's have now example number 4. Insert two geometric means between 36 and 256 over 3. So first is we're going to illustrate the given problem in example number 4. So that is 36, a sub 2, a sub 3, and the last term is 256 over 3. And then next is we're going to determine the value of a sub 1. So a sub 1 is 36, that is the first term. The last term, which is a sub n, is equal to 256 over 3. And the value of n is 4 since we have 4 terms in the given problem. So 1, 2, 3, 4. So therefore, the value of n is 4. Next is we're going to use the formula in finding the value of r. We're going to substitute the value of n, which is 4. And then the value of a sub n is 256 over 3. And the value of a sub 1 is 36. And then next is we're going to simplify. 4 minus 1 is equal to 3. And then we will copy the numerator, which is 256 over 3. And then next is we're going to determine the reciprocal of the denominator. The reciprocal of 36 is 1 over 36. And then if you're going to multiply 256 by 1, the answer is 256. And 3 times 36 is equal to 108. So 256 and 108, the greatest common factor of 256 and 108 is 4. So 256 divided by 4 is equal to 64. And 108 divided by 4 is equal to 27. So we have now the cube root of 64 over 27. And the factors of 64 are 4 times 4 times 4. So that is 4 cubed. And the factors of 27 are 3 times 3 times 3, or that is 3 cubed. And then if we're going to get the cube root of 4 cubed over 3 cubed, that is equal to 4 thirds, or 4 over 3. So the common ratio of the given geometric sequence is 4 over 3. Next is we're going to solve for a sub 2. So that is equal to a sub 1 times r. A sub 1 is 36. The value of r is 4 over 3. So we have now 36 times 4 divided by 3 is equal to 48. So again, 36 times 4 divided by 3 is equal to 48. So the second term is 48. And then next, for the third term, or a sub 3 is equal to a sub 2 times r. A sub 2 is 48. And the value of r is 4 over 3. So 48 times 4 divided by 3 is equal to 64. Again, 48 times 3 times 4. 48 times 4 divided by 3 is equal to 64. So the final answer now is the two geometric means between 36 and 256 over 3 are 48 and 64.
Thank you for watching. Please don't forget to like, share, and subscribe.